Hi friends, I'm sure you've played with a fidget spinner. Have you ever thought that this spinning toy is very similar to the structure of an atom? That's what we'll explore in this video. We'll see how the subatomic particles, the protons, electrons and neutrons are arranged in an atom. We'll also look at Thomson's and Rutherford's model of an atom. Listen carefully because towards the end, we'll do our top 3 questions on this topic. First, let's review the subatomic particles: protons, electrons and neutrons. In this video, we are going to learn how these particles are located in an atom. A scientist by the name of J.J. Thomson, who discovered the electron, proposed the plum pudding model of an atom. Now, by that time, the neutron particle had not been discovered, so the scientists were only working with protons and electrons. Now, what was his plum pudding model? He said that the electrons are like tiny plums sitting in this large positive pudding. Now, I don't have a plum pudding with me, so I'm going to use this watermelon instead. So if you look at the watermelon, this red part is like the large positive mass, and these tiny seeds are like electrons sitting in this large red mass of positive charge. Thomson's model of an atom was: an atom consists of a positively charged sphere with negatively charged electrons embedded or stuck in it, and the negative and positive charges are equal and opposite. So the atom is electrically neutral. Let's add Thomson's model to our concept board. Thomson's model explained the electrically neutral nature of the atom, but it could not explain the result of experiments carried out by many scientists. A scientist by the name of Ernest Rutherford came up with an interesting experiment that completely disproved Thomson's model. With his experiment, he ate up Thomson's plum pudding model or the watermelon model. That's refreshing. So let's take a look at what's the experiment he did. To analyze the structure of an atom, Rutherford and his students tried to bombard a thin layer of atoms with tiny charged particles. They wanted to study the deflection of these particles by the atoms. Now, how did he get a thin layer of atoms? I'm sure you've seen an aluminium foil. So that's pretty thin, right? Like the ones used in the kitchen to wrap food. But he used a gold foil because it can be beaten into an even thinner sheet than aluminium, since gold is the most malleable metal. Now, I don't have a gold foil with me, so I'm going to use this golden paper instead to represent the gold foil. Now, the actual gold foil is much thinner than this golden paper. The thickness of the real gold foil is only about 1000 atoms. Now, what are the tiny particles that were used during the experiment? They are called alpha particles, and they are positively charged. Each alpha particle is basically the helium nucleus, since it contains 2 protons and 2 neutrons. So what do you think is the charge of the alpha particle? That's right, it's +2, since there are 2 protons in it. Alpha particles are like tiny bullets that are emitted from radioactive sources such as radium. Now, I have these tiny red balls here which represent the alpha particles. So what did they do? They took the gold foil and bombarded it with these alpha particles. And they observed the scattering of the alpha particles by the gold foil. So that's why this is famously known as the alpha scattering experiment. Let's try to recreate Rutherford's experiment. For that, I need your help. So let's imagine we are going to magnify this thin layer of gold atoms here. And then we are going to study the scattering of these alpha particles by this thin layer of atoms right here. Let's use these balls to represent a layer of gold atoms. My gold atoms are green in color. The actual thickness of the gold foil is about 1000 atoms. But for simplicity, let's keep the thickness just as a single layer of atoms. And we'll bombard this layer of gold atoms with our alpha particles right here. Let's fire the alpha particles towards our gold atoms. As expected, you saw that most of them get deflected away or get rebounded back. Rutherford and his students also expected the same. But what were their observations? Exactly the opposite. Their observations were that most of the alpha particles passed straight through. Few alpha particles got deflected back by small angles and few were deflected back through large angles. And very few particles actually rebounded back to their original path. So to their surprise, they found that most of the alpha particles passed straight through, undeflected. It's almost as if the gold foil is empty, as if there are no atoms in there. So I'm going to go ahead and remove these atoms. Now, what did Rutherford conclude from his observations? Most of the space inside an atom is empty because they observed that most of the alpha particles pass straight through without being deflected. So the atom is basically hollow. Very few alpha particles are deflected, so the positive charge of the atom occupies very little space. Even fewer alpha particles get rebounded back to their original path. So all the positive charge and mass of a gold atom is concentrated in a very small volume within the atom, represented by these tiny green spheres here. So these are representing the positive charge and mass of the atom. So this is our new model of the atom. Let's perform the alpha scattering experiment once more with this new model now. And as you can see, most of the alpha particles go straight through without being deflected. Only a small number are deflected away and even fewer rebound back. So this model matches Rutherford's observations. Rutherford proposed the nuclear model of the atom, which states that there is a positively charged center in an atom called the nucleus. Nearly all the mass of the atom is in the nucleus. The electrons revolve around the nucleus in circular paths. The size of the nucleus is very small compared to the size of the atom. The neutron particle was discovered much later and added to the nucleus of the atom. So the structure of the atom looks like this spinning fidget spinner with protons and neutrons in the center and electrons spinning outside it. Let's add Rutherford's model to our concept board. Now we can fill up the location of the proton, neutron and electron in the atom. Now that we are done with the structure of the atom, let's move on to our top 3 exam-oriented questions on this topic. Here are the top 3 questions. I encourage you to pause here and try to solve these questions. I'll be posting a video on the solutions soon. You can find a link to the solutions video in the description below or search for it on my channel page. So I hope the structure of the atom is crystal clear to you now. So next time when you're playing with your fidget spinner, do remember that the spinning part is the electrons. The heavier particles, that is the protons and neutrons, are located in the center called the nucleus. And do remember to like, comment and share this video and hit the subscribe button for my channel. Thanks for watching.